Okay, guys, today we're going to go over our 7.1 part 2, or the 7.1 lab, over building atoms. So that's our assignment. Okay, so these are the questions attached to that assignment. Okay, it tells us to visit this website, click atom, click stable, unstable, click net charge and mass number. So I'm going to click atom. We're going to click stable, unstable. I'm going to click net charge and mass number. This is going to tell us some things about the atoms as we add parts. Question number 5 says, what are the parts of an atom in the buckets at the bottom? Well, here we have protons, neutrons, and electrons. I usually leave the electrons as lowercase just because it helps me remember that they're tiny and they're not part of this. Well, we'll see later on. I know it's not grammatically correct, but that's the way I write it. Number 6 says, drag a neutron onto the X and answer, what does a neutron do to the mass of an atom? So we're going to drag a neutron onto the X here. And look, we see that the mass goes up. The mass goes to 1. Increases the mass. The next question is, what does a neutron do to the charge of the atom? I think it does nothing to the charge. It does nothing to the charge. Now, problem 8 says to drag a proton onto the X and answer, what does a proton do to the mass? And then 9 says, what does it do to the charge? So we're going to look. We're going to add a proton. We're going to watch the mass. What's it do to the mass? Oh, it increases the mass. And if we look, it also increases the charge. It increases the charge. It made it a +1 charge. It added 1 mass, it added 1 charge. Next, we're going to do the same with the electrons. Okay. First question says, where does the electron go? So we're going to drag an electron onto the atom. Oh, and notice that it doesn't actually go to the center. It doesn't go to the center. It actually goes to a circle here, or a shell that we talked about in the last activity, part 1. So where does it go? It goes onto a shell, an electron shell. Next, we need to look, what does an electron do to the mass of an atom? So here we're looking at the mass number, right? We put an electron on there. It doesn't change the mass. So electrons don't change mass, or from the earlier notes, we know that technically they do, but for our purposes, electrons have no mass, right? So the electron does nothing to the mass of an atom. And what does it do to the charge? Well, we can see it had a 1 charge, and so this decreased the charge. +1 minus 1 is 0, right? So it decreased the charge. Okay. It decreased the charge. So in essence, we know, electrons are negative, weightless particles, or they appear to be weightless, right? Electrons are negatively charged, massless particles, or nearly massless. Protons are positively charged with a mass that is about equal to, got away from me, it's about equal to a neutron, right? Neutrons have no charge. They don't change the charge at all, but they do have mass. So that's what we've learned from the activity so far. Now, question 13 says, add 5 more neutrons to the atom and what changes? So we need to actually fix this. 1, 1, 1. Okay. It says 5 more neutrons. 1, 2, 3, 4, 5. And look, you see the mass went up here. Okay. What changes? The mass. The mass. It also became unstable when we did that. Okay, when we have a lot of neutrons, it seems to make the atom unstable. Begin to shake around. This is add 1 more proton to the atom. What happens? Well, so the mass went up by 1. Increased. The mass went up by 1, and the charge went up by 1. 15 says add more protons until the atom is stable. Okay, so we're going to add more protons. Oh, we missed something. When we added this proton, let's see if I can get a hold of it. It went from hydrogen to helium. Now it's helium. So we forgot to mention that, right? What changes? The mass increased by 1. The charge increased by 1. It became a helium atom. When we add protons, we're changing the type of atom it is. Earlier we talked about an atom's identity. Well, the identity of an atom has nothing to do with the number of neutrons or electrons, but everything to do with the protons. So the number of protons tells us what kind of atom it is. We'll see that here. It says add more protons until the atom is stable. What happens to the name of the atom as you add protons? So add protons until it's stable. Oh, there we go. It changes. The name changes. We don't know the names of all the elements yet. We can see that we've actually stepped up this chart. That with 1 proton, it was hydrogen, and then it was helium, then it was lithium, and then beryllium, and then now with 5 protons, it's boron. So with 6 protons, we could probably predict it would be carbon. And 7 would give us nitrogen, 8 oxygen, 9 fluorine, and 10 neon, and so on. How many protons and neutrons are in the stable atom? Well, there were 1, 2, 3, 4, 5 protons and 6 neutrons. Help us remember they're big. And the next question is, how do we make an atom stable? And your predictions might be different, but basically what we know is that when there are just about the same number of protons and neutrons in an atom, when they're about the same, we have atoms that are stable. Okay? We'll talk about what this means later, but the short version is they don't fall apart. actually, if you guys remember the radioactivity, when an atom is not stable, then it is radioactive. Literally, the atom itself falls apart. We'll talk about that. We'll talk about isotopes later. Okay. Remove the electron from the atom. What happens to the charge? Well, we already know what's going to happen. So there's a couple of neutrons. I'm going to remove the electron. The charge goes up. The charge goes up. Add electrons back to the atom until its net charge is 0. Where do the electrons go after the second one? So adding electrons, 1, 2, the net charge. I need 3 more to make the net charge even, 0. So now it's down to 2. Now it's 1. Okay. Now it's a neutral atom. But we notice something. This first electron shell, this first circle here, it'll only let me put 2 electrons on there. No more will fit. And I think that's what our question was trying to show us here. Where do electrons go after the second one? On to an outer, no, onto another electron shell. The next question is the atom, the new atom, is it larger or smaller than before? Well, if the electron shells are larger, if it's outside of this one, then it is larger. The new atom is larger. As atoms gain protons, they will attract more electrons, and electrons, only so many electrons will fit in each shell, so as it gets more electrons, the atom becomes larger. How many protons and electrons are there in the atom now? Well, let's look. It looks like we've got 5 and 5. How do we make an atom have 0? Atoms have a 0 charge when they have exactly equal numbers of protons and neutrons. So the stable thing, it has to do with roughly, right? Like we have 1 more neutron than protons. That one's a little more complicated. But for neutrality, for positive, negative, we just need exactly equal atoms have 0 charge. Exactly. Static electricity is if an atom has too few electrons, and you or a sample, a group of atoms, a molecule, if it doesn't have enough electrons, then when you touch it, it will take your electrons. It will add positive charge to you by removing your electrons. Or likewise, if an atom has too many electrons, then it wants to give them away, and it might shock you that way with a positive discharge, or rather a negative discharge. It's complicated. Charge moves in the opposite direction to the particle, and that's a whole other thing we haven't gotten into. But when you get shocked, it's because nature is trying to even out the electrons so that all the atoms have their preferred number of electrons. Okay. So now we know that atoms are made of protons, neutrons, and electrons. Neutrons have mass but no charge. Protons have a mass and a positive charge. Electrons, well, they are on the outside of the atom in shells. They have no mass, but they have a negative charge. Okay. And if atoms have a really unbalanced numbers of protons and neutrons, then they're unstable and they'll fall apart and cause radioactivity. Okay. As atoms gather more electrons, they go into outer shells and the atoms become larger. Okay. And to have a neutral atom, atoms need to have the exact same number of protons as they do electrons. So the same red particles as blue particles, the same numbers. Okay. All right. Thanks for playing. See you next time.